This is lesson 4.1.1, what is the connection? Finding connections between representations. This is day 2 out of 2 days of our 4.1.1 lesson. In chapter 3, you studied different ways to represent patterns. You organized information into tables, graphed information about patterns, and learned how to find the rules that govern specific patterns. Starting today and continuing throughout this chapter, you will find connections between different representations of the same pattern. You will also explore each representation in further depth. This work will develop efficient ways to go from one representation to another. By the end of this chapter, you will have a deeper understanding of many of the most powerful tools of algebra. So please follow along. Make sure that you have a pencil, and we are going to be working through our 4.1.1 lesson here together. In problem number 1, this is an introduction and review. For the pattern below, draw figure 0 and figure 4. So in order to help us find what figure 0 and figure 4 look like, we got to find some information out here from what is given to us in the first 3 figures. So in preparation for that, I'm just going to write figure 0 and figure 4. Now I'm going to start counting up in this pattern to see if I notice anything here. Now I notice that we got 1 tile on the wing right here, and then it grows to 2, and then it grows to 3. Those 4 in the middle out of each of the patterns, they stay the same. But now the other end is changing as well, so it might go from 1 tile here to 2, and then to 3. On the top here, we go to 2. There's 4 there. It's pretty safe to assume that we jumped 6. So it looks like it's adding 1 extra one on the bottom, and then adding 2 extra on the top little part right there. So for figure 4, let's just start drawing it, and everyone, it doesn't need to be a beautiful work of art. So if we have 3 on the bottom, it's going 1, 2, 3, so we need to have 4 on the bottom. 1, 2, 3, 4. I'm going to have my 4 tiles in the middle. And then if we're going 2, 4, 6, there should be 8 on the top. So 1, 2, 3, 4, 5, 6, 7, and 8. Your figure 4 should look something like that. Now, we followed that pattern. I'll even draw in our little marks here so we know that we followed the pattern correctly. And if we're going to go backwards to figure 0 now, we have to go backwards with our number. So if it's going 4, 3, 2, 1, there's actually going to be 0 tiles on that bottom. That middle we know was going to stay the same. So there's our 4 tiles with nothing on the bottom. And then for the top part, it's going 8, 6, 4, 2. So there also should be 0. So there's our 4 tiles. If you need to pause at any point, please pause, copy down, and then when you're ready, unpause, and we'll pick up with our table here. In A, it says represent the number of tiles in each figure in an XY table. Let X be the figure number and Y be the number of tiles. So we know in a standard table that X is always on top and Y is on the bottom. Now the label for the X, it says let X be the figure number. So I'm going to write in figure number. And it says let Y be the total number of tiles. So we're going to say number of tiles. Now the figure number, guys, is just the number that we see below the figures, and that's figure 0, figure 1, 2, 3, 4. So the figure number, I'm going to go 0, 1, 2, 3, 4. Now, our y is the total number of tiles in each pile of tiles for each figure. Now we're going to ignore our little drawings with those numbers because we got to count up how many each pile has. I see 1, 2, 3, 4. So we go 4. In figure 1, we got 1, 2, 3, 4, 5, 6, 7 tiles. In figure 2, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And guys, I'm actually already starting to see a pattern in this table. It looks like it is increasing by 3 each time. Now we can use that number or that slope to predict how many tiles are going to be in each figure. Now, following that pattern, we'd have 13 and 16 in figures 3 and 4. If you don't trust that, you can count up and see in figure 3 that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it works out. And there would be 16 here in figure 4 as well. Now we've found our slope. The other thing that I told everybody to get in the habit of finding would be our y-intercept. Recall, our y-intercept is the number that lines up next to 0. That would be presented right there in our table. So maybe I would write a little note on here, just so you remember that that's where our y-intercept and slope is visible. If you need to pause, please go ahead and pause. Otherwise, we are going to proceed. In part B here, it says use the table to graph the pattern. Now, whoever made this graph for us was nice, and they already made our axis for us. There's a couple things that are missing on this graph. We're missing our x and our y labels. We have our 0, that's the origin. We also need our labels. Guys, they told us let x be the figure number. We also labeled it in our table right there. So let's go ahead and write figure number. Our y, according to our sheet here, is the number of tiles, or the total number of tiles. So I'm going to go ahead and write number of tiles. So we know when we're looking at this graph what we can be saying specifically about the data. Now, according to the table, at 0 on the x, we have 4 tiles. So our figure number runs x ways horizontally. If that's 0, our first point is going to be at 4 according to that table. Our second point is 1, 7. So we're going to go over to 1, but I don't see a 1 on here. It's counting by 2's. 1 is going to fall halfway between 0 and 2. There's no 7, but 7 is going to be halfway between 6 and 8. So it'll be about 1, 7. Our next point is at 2, 10. So we go over to 2, we go up to 10. Third point, 3, 13. Our fourth point, we go over to 3, up to 13. And then last but not least, 4, 16. So we go over to 4, and we go up to 16. Now, what we should do is you should get a ruler, and we're going to connect the dots here. By now in class, guys, we should know that this line is linear. And we know that it is linear because it is a straight line. Now these linear lines can be used to make predictions. For example, if we wanted to predict without adding it to the table, what number 5 would be at. Now, all of us know that the fifth figure would have 19 tiles on it. But if you go to point 5 on our graph, so we go from 5 and we go all the way up, we see that at 5 there, it about this line touches about right here. I'm going to draw on a dot right there at 519, because if you measure that dot, it lines up with 19 on the y-axis. These graphs can be used to make predictions as well, outside of using an equation. So that's what they said here. Without drawing figure 5, predict where the point would lie on the graph, justify your prediction. We justified it by laying it on our graph here. So we drew our linear line and measured the line at the y-axis to find that 5 would be at 19. And I wrote it as an ordered pair right there. Remember, in ordered pair form, x goes first, then y. X in this case would be figure 5 would have 19 tiles. So I might write that down as well. Equals 19 tiles. That relates to the context, guys. Now, that concludes our lesson for the day.